Hind students, I am Dinanath, Department of Electrical Electronics Engineering. Today I will give you a brief about the sensors. Basically, I will give you one or two type of sensors, what is sensor technology which I have discussed here, and I will discuss important concept that is called PNP and NPN types of sensors, and how this PNP and NPN sensors are utilized or integrate with this other devices, which kind of things I have discussed in this lecture. So these topics are incorporated on the subject industrial automation and control, and this topic are mentioned in the unit 4 of this code KEE053. So, first of all, I will brief about the sensors, and I will discuss in general term what is sensor. So, this is sensors is the device which is basically sense the in the environment, physical environment. So, the physical environmental may be anything like light, heat, and the motion, moisture, their pressures. Pressures, humidities. So there are different atmosphere phenomena are there. So these phenomena, different conditions, they can be sensed directly with the help of different kind of sensors. Like if we want to measure the heat, what amount of heat are there in the environment, that can be measured with the help of heat sensors. So for the every aspects in the environment, there is a specified sensors are deployed to measure the environmental quantity. That quantity is measured with the help of different kind of sensors, and further this role of sensor is to convert it into the electrical quantity into the some readable quantity. These are the rules of the sensors. So in their the major advantage of these sensors is that there is a no direct contact with the physical quantity. Like if we want to measure the moistures, what are the moistures in the environment, so we cannot contact sensors to the moistures. They are separated by some they are separated by medium, but not directly connected to that. So that's why this sensors life and the flexibility of this is very much higher about the sensor. So which is written here, the sensor is a device that detect and respond to the some type of input from the physical environment. So in the physical environment, there may be anything like a light, there may be heat, there may be motion, there may be moisture, there may be pressure, there may be any kind of environmental conditions. So this output of generally signal is converted into human readable display at the sensor location, or transmitted electronically or network for the further processing for the end users. Like general sensors we use in a we use in our home, we use in a lift, door system, and the different kind of industrial sensors are there. They can use in a different kind of industries. So this another if I discuss the sensor, there is another term, that is the term known as transducer. So the role of transducer is that is the quantity is converted into any other form. Like in a sensor we converted into electrical quantity, but in a transducer the feature of that, they convert one form of energy into the another form of energy. So in the transducers, basically signal conditioner blocks are present in the transducer. They can convert in one form of energy into the another form of energy. So a bit going to the definitions which I have discussed already in respect of sensor. So sensors is a physical changes occurs in a surrounding and converted into the readable quantity, or it convert into the electrical quantity. This is the function. be talking about the transducer is a device which actuate transform the energy from one form to another form of energy. So, what are the components being used in the sensors and transducer is that we use the component, we use sensor itself is a component, major component, but in case of transducer we use sensors to sense the physical quantity, and we use the signal conditioning block to convert any other form of energy, like electrical to mechanical, mechanical to electrical, or any vice versa, any form of energy that with respect to that signal conditioning blocks are used. So, now coming about the functions. So, the function of sensor is that it detects the changes and induces the corresponding in form of electrical signal. But in case of transducer, this is the conversion from one form of energy into the another form of energy, which I have discussed in a discussed earlier. So, what are the examples of sensors? So, there is a different type of sensors is that like proximity sensor, which I have discussed later on this lecture, like magnetic sensors for the measuring the magnetism around the atmosphere, accelerometer sensors to measure the speed, light sensor, we use barometer sensor to measure the pressure, gyroscope. These are the different type of sensors in a general use, regular by use, or in we can it can be used in the industrial use. And another transducers like a thermistor, potentiometer, thermocouple, through that we can convert one form of energy into another form of energy. So, these are the basic difference between the sensors and the transducers. So, what about the advantages of sensors? So, as I discussed earlier, that is there is a no physical contact and there is a no stress. This is the major and most advantage of the sensors. They are contactless, so therefore they are having no any kind of stress, electrical or mechanical stress are not there in a sensors. uh, all another advantage is that there is no wear and tear, because there is no moving part, only electronics device parts is there in the sensors. There is no rotational or kind of operations are going on the sensors. So, this is no wear and tear, and hence there is a long life, because there is no physical contact with the environment. Another thing is that it is contactless, and therefore they are maintenance free. We can talking about their maintenance, their life, they are having very higher. They are having electronic high precisions. This is if we go about the precision wise, they give the high precisions measurement with the help of sensor. It can be protected and safe switching in a harsh environment. This is another advantage. They are having high switching rate, as they are using mostly the electronics devices. So, we know the electronics nowadays electronics devices are utilized day by day, and their size will be reduced, as well as their switching rate, that is on off conditions, will be very fast. So, they are having high switching rate. These are the most features of the sensors. Another one is that this is potential free contact, and thus there is no pawn or false pulses. They give the exact and accurate predictions or indications we can get from the sensors. Now, the role of sensor technology with respect to the uh, latest one, we can use what happened with the we use the sensor technology in the now in the system. So, this is the sensor alarm. Their system operates about the failure of any of the subunit manufacturing system. They can use it, helps operator to reduce the downtime of complete manufacturing system by the carrying out the preventive measures. So, these are the another advantage by using the role of sensor technology. It reduce requirement of skilled and experienced labor. This kind of work, that is the skilled and experienced labor work, can be done with the help of sensor itself. So another thing is that about the sensor is that it gives the ultra precision, and product quality can be improved. Their quality, if we talk about the quality that we get with the sensor technology, which is very high. Now come to one of the major use sensors. With this limited period of time, I will discuss only one or two types of sensor. One of them is the proximity sensor. The name suggests the proximity means it can detect and give signal whatever with the near about the objects. According to the nearing object, they detect and give the signal further. So, this proximity sensor is a sensor. It is able to detect the presence of nearby object without any physical contact. So, it detect whatever be the object nearby. Accordingly, they give the signal. That is why their name is called proximity sensor. So, proximity sensor often emits the electromagnetic field or beam of electromagnetic radiations. They may be electromagnetic field or electrostatic field. They may be give the electromagnetic radiations, that is infrared, and its looks changes in the field and give the return signal. The object being sent is often referred to the called proximity sensors target. Uh, Accordingly, the target will be decided simply. And the proximity sensors can have high readability, reliability, and long functional life because of absence of mechanical part. There is a no any kind of mechanical part is there. Only some electronics equipments are incorporated in this proximity sensors, and the lack of physical contact between the sensors and the sensed object. The proximity sensors come in a wide variety of shape and size, and they are classified according to the type of principle, and they are either work on electromagnetic principle. According to that, they are different kind of different proximity sensor. If there is electrostatic field is there are electrostatic proximity sensors are there. So, according to the working, according to the working, their classifications are done according to the object, what objects we detect, nearby object will detect. Accordingly, their sensors will be classified. Now, proximity sensors type. What kind of proximity sensors is there? So, based upon their working and the range, what they measure, they are classified as inductive proximity sensor, they are capacitive proximity sensor, they are optical proximity sensor, or ultrasonic proximity sensor. So, these are the different type of proximity sensors. Now, coming to the inductive proximity sensors, you can see this is one of the figure of inductive proximity sensors. This is similar like a capacitive and proximity sensor. Capacitive proximity sensor is same look like. So, inductive proximity sensor is a sensor which is shown in this figure, is used to detect both ferrous metal, means if we talk about the ferrous metal, means that contain the iron material, and can be magnetized, and non ferrous material such as what we use to conduct the electricity and copper. So, basically any metal, they can use the metal metal atom that contain the iron or some copper material. They can, the flow of electricity is possible on that. So that can of measurement can be done with the help of this proximity inductive proximity sensor. So inductive proximity sensor operates under the electrical principle of magnetism when a fluctuating current induces the voltage in the target object. So these are the basic principle of the inductive proximity sensors. In detail I will discuss in the next slide like this. And the working, now first of all I will discuss about the what are the major component in the inductive sensors, that is the electrical coil. This electrical coil are responsible for the generations of electromagnetic field. Basically these inductive sensors are are used for the electromagnetic field generations. They are used for the they are using oscillator circuit, the or it is called voltage regulator is used to high frequency wave generations we can generate with the help of oscillator signal. They are using the trigger circuit, they can basically use for the on and off signal can be provided with the trigger. If they come on this range, they are triggering on, means sensors are on, otherwise they are turn off. This can be operations can be helped with the trigger circuit. There is another block there, that is amplifier is also there to amplify the signal which is giving to the load circuit. Or it can be explained with this diagram. There is a target, this object is saying that this is the wave, that is wave is generated with the help of oscillator and electrical coil. If there is a no any target, means target is away from the this range, that range will be uh, that is proximity sensor, that is inductive proximity sensor. If they are not coming on that range, on that case the waveform will be very high. But as the object nearby, nearby means they come on the range, target is come on the range of this sensors, the waveform is reduces, and if the target is present, target is object present, similarly target, the trigger circuit will be trigger and output is showing like this, means it indicates that there is some target on the range of the sensors. So this arrow or this waveform is shown like this straight line up to that when the target is present. If there is a target is again go away, then the waveform is again makes wider. So based upon what the target is come near to the sensors or sensors, their operations have been changed, and that operations will be done to the load, that is with the help of trigger circuit. So in this see the diagram another way, these are the electromagnetic coil, this is the filter, this is the oscillator to maintain the frequency, this is the Schmitt circuit or triggering circuit to on or off the circuit, this is the amplifier, the output they can be amplified further. So inductive proximity sensor contains a certain type of solid state control system. It contains an oscillator circuit that generate a high frequency magnetic field. When metal object enter the field, it did disturb the magnetic field. These disturbances result the change in a state in the high frequency circuit. Now come to advantages of inductive proximity sensor. So this is the contactless detection, as the every sensors does, they having not direct contact to the system. This is environment adaptability, resistance to common conditions seen in an industrial area such as dust and dirt. It is capable and versatile in metal sensing, they are having high switching rate, they are having no any moving part. So, it is ensuring a long service life. Now, the disadvantage of inductive proximity sensor. So, lack in detection sense, basically they having not range will be very wider range, that is average range is around of 60 mm, and it can only use to detect the metal object. And another one is that is external conditions like extreme temperatures, cutting fluid or chemical effects on the performance of the sensors can be affected. These are the major disadvantages of while using of inductive proximity sensors. Now, another proximity sensors, that is known as capacitive proximity sensors. This is a similar kind of principle. They are working on change of capacitance principle they work. So, as per the name suggests, the capacitive proximity sensor operate by the noting a change in the capacitance read by the sensors. So, amount of capacitance, this is varies depending upon the size and distance of the sensing object. An ordinary capacitive proximity sensor is similar to the capacitor, which is two parallel plate where the capacity of the two plates are detected. It detects the change in the capacity generated between these two poles. The detection of the object depend upon their dielectric constant. So, basically in the sensor, whatever will be the dielectric, it neglect the air will be not mentioned. Apart from the air, if they come on that range, their capacity will be changes, that is the capacity of the sensor object and the object, that is a metal object or non metal object, come on that range, their capacities between them will be varies, that changes will be detected, and accordingly the sensing signal will be provided. This is the major role of the capacitive proximity sensor. So, if we go to the blocks uh, of capacitive proximity sensors, they having same like a plate, they are using again oscillator, which is used in a inductive type of sensors. There is a trigger circuit to on and off the circuit. The output switching signal according to the trigger circuit what is given, it is given to the load. So, if this is, let us suppose this is the target. So, if their target is far away, that means on that conditions there is no detection signal will be given, sensors will be off, there is a no role of triggering circuit. But if the target is come around the range of the range on the proximity of the sensors, their capacitance will be changed. Then in this capacitance will be changed, as the capacitance will be changed, there correspondingly this is capacitance will be changed, the capacitance between them, the electric field will be changed. As the field will be changes, the triggering circuit will give the signal further to load to be on or either off, that can be detected. Similar like inductive proximity sensors. So, what are the major difference between the inductive and capacitive proximity sensor is that the inductive proximity sensor use the magnetic field. So, magnetic field principles they are used in a inductive proximity sensor, and in the capacitive proximity sensor they are change in capacitance in use in electric field. So, this is due to the electric field, they are using the magnetic field. So, in order to sense by an inductive sensors, an object must be conductive. This is obvious in both of the case. The limit suitable to targets the metal objects in order to sense by the capacitive sensor, the target does not need to be conductive. These are the major difference. One more major difference between the inductive and capacitive sensor is that, like in case of inductive sensors, only metal objects should be available or nearby the target is there, so that the inductive sensors will be operated. But in case of capacitive proximity sensors, there are no need to be any metal or non-metal objects should be present. Accordingly, they will give the signal, sensing signal can be provided. So, so capacitive sensors can measures or give provided the signal with the either they are metal object or either they are non metal object. In both of the cases, they give the sensing signal. So, what are the advantage of capacitive proximity sensors? This is again, this is contactless detection. This is similar like inductive sensors. There are wide variety of material can be detect, which in case of material selections, they will find the limitations. In case of inductive sensors, only the metal objects they detect, but they can detect metal as well as non metal objects can be detect. Another one is that it is able to detect object through non metallic walls and with its wide sensitivity band. So, it is used for well suited to the used and industrial environment. It contains the potentiometer that allow user to adjust the sensor sensitivity, such as only wanted object will be sensed. They having no moving part like any sensors, so ensuring they having longer service life. Disadvantage only that in case of capacitive proximity sensor is that they having again suffers from the low range, and they having higher price as comparisons to the inductive sensors. Now come to PNP NPN sensor concept and for the interfacing in the PLC and other devices. So, as proximity sensor used to detect object without making any physical contact. So, there are the two they can be used, they are mostly used, they are available in the range of either in 2 wire or they are available in 3 wire proximity sensor, but 3 wire proximity sensors are more popular or widely used in the industry or for the any connections. So, there are two types based upon their based upon their output. They are either we called as NPN type of sensor and they are either PNP type of sensor. So, what are the major difference between PNP type of sensor or NPN type of sensor? So, basically NPN proximity sensors provide an active low output, and means their output of the sensor is connected with the ground, and this type of sensor is known as sinking sensors. This NPN sensors are used for the sinking sensors and it gives the active low output. Another PNP type of sensors, they give active high output, and this can be used for the sourcing type of sensors. So, these are the basic difference between the PNP type of sensor and NPN type of sensors. Their output will be positive in the case of PNP type of sensor, the output will be negative or 0 in case of NPN type of sensor. This is the major difference. Like if we go 3 wire concept, which is widely used, that is 3 wire PNP or 3 wire NPN. So, in case of 3 wire, this one wire is that is the brown wire is indicated for positive sense. This black wire is represented for negative sign, that is negative, and this blue wire is represented for the 0 volt circuit. So, this is the 3 wire number 1, wire number 2, wire number 3, wire number 1 positive, negative and 0, and here P stand for switched positive, that is the positive. First P is represent the what where they switch, that is a switch positive. Like in this case, their PNP type of sensor we know the output that is the black will be positive and it's connected to negative, means they are positive type of sensors, that is sourcing type of sensor. So another I will talk about the PLC or any kind of load, they can be sinking type, they must be sinking type. Or if in another case, that is NPN type of sensors, there is switched to be negative, they are switched to be negative. So this is sinking type of sensors. So the load or any PLC should be nature of sourcing type. So this is sink, so load will be source, this is source, so load will be sink. So that concept we wired with this, the interfacing any PLC or any kind of device. Like this is the motor, this is the sensor, which is connected to the some contactor. So you can, we will find 3 wire, that is positive, 24 positive, this is output, and this is 0 volt. So this output will be positive because there is a PNP type of sensor, the load will be negative, and the another hand this is NPN type of sensor, output will be negative. So the this connected to the positive terminal. So through that we can imagine, and another thing is that they can mentioned on the sensor itself on the nameplate rating. This is with respect to the PLC, this is output will be given to this is PNP type of sensors, because and this is a PNP, then this PLC will be this is sinking, this is source signature. Similarly, this is sinking type of wiring, and this PLC should be sourcing type. So this kind of concept we are using while we connect NPN type of sensors or PNP type of sensors. So these are the some references we have been using, I am using for this preparing this lecture. Thank you for the listening.